Welcome back, Algebra 2 students. Today we are going to cover the second part of section 1.6 and look at how we solve linear systems by using the process called elimination. So here's our steps. First, we put the equations in standard form. Okay, that's our ax plus by equals c form. We determine which variable we want to eliminate. So we'll talk about that. We want to compare coefficients. So keep in mind that we might have to do some multiplying. We might have to multiply one of the equations or possibly both to get the same coefficients for a certain variable. And once we've done that, then we can add or subtract the equations. Once we've solved for one variable, we do the same thing we did with the other method and we plug back in to figure out what the other variable equals. And then lastly, we always check our solutions. So let's get started. Here's example 1. So we want to look to see, do we have opposites for coefficients for either of the variables? And here we do for the y's, right? I have a plus 1y and a minus 1y. So if I add these two equations together, plus y minus y cancels each other out. So they're out, right? They drop out of the equation. Adding up x and 3x, I get 4x is equal to 5 plus 7, which is 12. Dividing by 4, I get x equal to 3. So now I can go back to either equation and I can plug in. I'm going to plug into the first one. That's a very simple equation. So 3 plus y is equal to 5, which means y is equal to 2. So my final solution, remember, is a coordinate. Both of these are graphs of lines, and the solution is the point where they would meet or intersect. So my solution is 3, 2. And then I'm going to do a quick check. So if I plug into the first equation, I get 3 plus 2 does equal 5, so that checks out. On the second one, I get 3 times 3 minus 2. Does that equal 7? And it does. That's 9 minus 2, which equals 7, so that checks out. So do that quick check. For a lot of these, it doesn't take very long, and it's worth it to catch your errors. Example 2. So here I've got 4x and 4x. So I have this same coefficient, but I don't have opposites. So what I'm going to do is take the first equation, can be either one, doesn't matter. I'm going to use the first one, and I'm going to multiply by -1. That means every term, every part of this equation gets multiplied by -1. So the new equation, I'm going to write below this one, becomes minus 4x minus y equals -7. Now I can add these two equations together. So I have the opposites. These cancel out. I get -3y and -9. So y is equal to +3. Again, it's my choice. I'm going to go to the first equation and plug y into that equation. So subtracting, I get 4x is equal to 4. So x is equal to 1. So my final solution is 1, 3. I can check that solution, again, by plugging into both equations. So in the first equation, that's 4 times 1 plus 3, and that does equal 7. So that works. In the second equation, 4 times 1 minus 2 times 3, and does that equal -2? So that's 4 minus 6, and yes, that does equal -2. Okay. Examples 3 and 4, I'd like you to pause the video. Okay, try both examples 3 and 4. When you're done, come back and we'll compare solutions. Okay, let's see how you did. So for example 3, I got the solution 5, 4. And you can see my check over here on the side. If you got a different solution, then go through and check the work, compare our work. For example 4, I got the solution -1, 9. And again, here's my check on the side. So if you got a different solution, check through the work. If you feel maybe I made an error, then certainly bring it up in class. Okay, now for this type, if you notice, let's see, we don't have opposites, okay? In example, excuse me, example 3, we had opposites -3y and +3y. In example 4, let's see, what did I do here? Okay, so we had the y's, so I made one of the y's a negative, which means I have to make every term of that equation negative. Okay, opposites. So that gave me this new equation here. This one is different. Here we don't have opposites. Okay, we don't even have like coefficients. So this is the case where I need to multiply by a number. So what I'm going to do to make it as easy as possible is multiply the second equation by a 2. Okay, so if I multiply every term by 2, I end up with 6x minus 2y is equal to 10. And then I'm going to bring the first equation down below it and add these two equations together. When I add them, I get 8x, the y's cancel out, and I get 16. So x is equal to 2, and then I can go back and plug in. I'll plug into the first one. So it's 2 times 2 plus 2y is equal to 6. So 2y is equal to, I'm subtracting 4, so y is equal to 1. So my final solution is 2, 1. And we can do the quick check. We have 2 times 2 plus 2 times 1. Does that equal 6? 4 plus 2, yes it does. In the second equation, we have 3 times 2 minus 1. Does that equal 5? We get 6 minus 1, which does equal 5. Okay, so example 6. This one is also different because now, if you notice, there's not just, I can't just multiply one equation by a number to make opposites. So this is the case, and this is the last case, where you have to multiply both equations. So it's unfortunate. This is the most work probably of any of the problems, but we're going to multiply, let's see, here I have the opposites, at least for the y's. So I'm going to focus on eliminating the y variable. So I'm going to multiply the first equation by 3 and the second equation by 4. Okay, that'll give me a positive 12y and a negative 12y. So I'm going to write the new equations right down here. So the first equation becomes 9x plus 12y equals -3. And the second equation becomes 16x minus 12y is equal to 28. Okay, when I add these up, I get 25x. The y's cancel out, and I get 25. So x is equal to 1. If I plug that back into, it doesn't really matter, I'll just choose the first equation. I get 3 times 1 plus 4y equals -1. So 4y is equal to -4. So y is equal to -1. So let's do a quick check. So 3 times 1 plus 4 times -1. Does that equal -1? Yes, it does. In the second equation, 4 times 1 minus 3 times negative 1, does that equal 7? So this becomes 4 plus 3, which does equal 7, so it checks out. Okay, so you go ahead and try example 7. Pause the video. When you're done, come back and we'll compare solutions. Okay, let's see how you did. So I took the second equation multiplied by negative 2. That gives me this line here. And then I brought the first equation down and added them together. So go ahead and check the work. If you didn't get negative 1, negative 1. Okay, let's go on to, we're going to go to example 9 about the amusement park. We have a trip. It's the senior class is going to the amusement park, and they're riding on buses and taking vans, and let's see, there's 2 different high schools, high school A and high school B. Go ahead and see if you can set this problem up and figure out how many students can a van carry and how many students can a bus carry. Pause the video. When you're done, come back and we'll compare solutions. Okay, so we have 2 equations. This is for high school A. I let V equal the vans and B be the buses. Here's high school B. This is that unfortunate case where we have to multiply both equations. So here's my new equations. When I add those equations together, I end up with V equaling 18. Plugging that back in, I get B is equal to 58. So there are 18 students in a van and 58 students in a bus. So if you have any questions about any of these problems, keep track of what you want to ask about and be sure to bring it up in class. I hope you enjoyed the rest of this lesson and have a good day.